All right, we have a question here, chemistry more concept, which says 5.8 grams of iron, of triion tetraoxide reacted completely. Supposed to be triion, so triion like that. Completely with aluminium to form iron and aluminium why was I putting double something? Just a minute. Why was I putting double L? Aluminium. So aluminium. Even here, aluminium. Okay, so this is the equation. It's balanced. And it says calculate the mass of aluminium which reacted. So which aluminium? This one here. We want to know the mass of aluminium that reacted if 5.8 grams of aluminium, of triion tetraoxide reacted with aluminium. But how much of aluminium did what? In fact, react. So to do this, follow me. There are two ways, okay? There are two ways, and all the ways, it's up to you which one you follow. The first method is what we call the mass ratio, because it's a straightforward one, right? It's called mass ratio. In mass ratio, we are going to get the to react because we're looking for this one given this one. So we are going to say this one in ratio with what? Aluminium. The mass given for let us now find the relative molecular mass for this one and for this one. Now for this method called the mass ratio, these numbers in front, they're included. Take note, the other method, those numbers are not included. So let us find the molecular mass for this one and the molecular mass for this one. So the molecular mass for this one, I'll do it from here, including the 8, okay? Then everything I'm going to multiply by 8. So oxygen mass number is 16, we multiply by 4. Iron mass number is 56, we multiply by 3. Here we get 64. Then we have 56 by 3, 168. Then we add 168 together, I'm getting 232. But I'm going to multiply by what? 80, because 8 is there. So 252 by 8, I'm getting 2016. So here I'm going to put 2016. I also find for aluminium, aluminium has got 8, like this. Mass number for aluminium is 27, but there's 8 there, I multiply by 8. So 27 by 8. Ooh, sorry, supposed to be 3 here. Sorry. So I put a 3 here. Put a 3 here. So 232 by 3, 696. Put 696 here. Then here 27 by 8, 216. Then this is just the ratio of the two in terms of their masses given. Now let's look at the reacting masses. We have 5.8 for this guy here. So we put 5.8 here. While here we don't have, then we cross multiply. So when you cross multiply, we get x is equal to 5.8 multiplied by 216 over 696. So x, which is the mass for aluminium, I'm getting 1.8 grams. This is the mass for aluminium. This method is quite straightforward. is quite straightforward. While the other one, remember, we are going to keep, for the other one, like I said, these are not included. So here we are going to remove 8, and you are going to remove what? 3. So let me just keep 216 and 232. Sorry, 216. Let me just keep 27, so that we can erase this. The second method is what we call the mole ratio. The mole ratio method. Under the mole ratio method, let me even write it here. We first have to find the number of moles of the given mass, which is number of moles of this guy. Number of moles is equal to mass over molar mass. The mass is 5.8. Molar mass, I'm going to put 232 without this 3 in front. 232. And the number of moles, I'm getting, sorry, so 5 point by 232, 0.025 moles. Now we are going to again do a mole ratio of Fe3 and 4 to what? To aluminium. In terms of moles, how many are there here? 3. This one has got what? 8. So we're going to say 3 to what? 8. But these moles, therefore, this guy here, so put them here. And here I'll put what? X. So if I cross multiply, I'm going to get 0.025, okay, times 8. So say times 8, then divided by 3. I'm getting 0.066666 like that. Okay, that's what I'm getting. Like 0.06 something. It's like 0.06. Let me just say 7, because they are all 6s like that. These are the moles of aluminium. This is stage 1, stage 2, then stage 3. We find out the mass. Remember, coming from that formula, number of moles is equal to mass over what? Molar mass. So we are saying mass is equal to number of moles multiplied by what? Molar mass. So mass, here we remember just answering question A. Number of moles is 0.067 times the mass is 27. This one, the molar mass. Then multiply that by 27. I'm still getting the mass of aluminium, 1.8 grams exactly. I think that's what you also found. So I don't know which method we are going to go for, but it's up to you. But it all has got precautions and cautions to take. Just like I have told you, take note of those. B says calculate the mass of iron, so we need to find the mass of this one. Well, to find the mass of this one, we can even use mole ratio, or we can use this mass ratio. It will still give us the same. We can use mass ratio. It will still give us what? The same. Okay, now here we are comparing this one with what? Iron itself. What did we have here? We had 696. 696. What of for iron here? So we have, what is the iron is 56 times 9, so 56 times 9, okay, 504. So we're putting 504 here. Then here we've got 5.8. Then you put what? X, and cross multiply. So that one times 5.8, we divide by 696. So the mass of iron is 4.2 grams. If you want, you can use this method. Just try. It will give you the same, because it is just the same. Alright, so that's how this question was supposed to be tackled, and I really hope that it made sense to you. And you can subscribe to my YouTube channel and follow me on TikTok as well as on Facebook. Moreover, please don't forget, we are here for you. You can start your online classes. We are very much affordable. We are going to be with you until you write your final paper.